2.3. We're graphing equations of lines today. This should be largely review. A couple of things that maybe you haven't seen before, but mostly review.
Has anybody finished it in class?
Yes. I am recording, by the way. Slope-intercept form of a linear equation. Y equals mx plus b. You should have all seen that before. What's the m stand for? Slope. Okay, what's the b stand for?
Y-intercept.
Yeah.
Y-intercept. And when I talk about the y-intercept, what is that?
Where it crosses the y-axis.
Where it crosses the y-axis. Very good. So, when we look at, I'll leave it there. Right, sit down when you start at notes. Right behind Doug's good. Nope. First 3 rows. Okay. Y equals 2/3 x plus 1. My y-intercept is 1. So that means that the point 0, 1 is on my graph. 0, try that again. And I have a slope of 2/3. Remember, slope is rise over run. So from here I go up 2 over 3. 1, 2. Now, look at that point. What is my new point? 1, 2, 3. 0.33. Now, if I have 2 points, that's all I need to determine the line. So at this point, I can draw a line through my 2 points. Set that line. Now, when you're drawing your graphs today, I want you to extend your lines so that they're crossing the x-axis or the y-axis. Use your space. If you have a graph this size, don't draw a line this big. Draw it so it uses up your space. So, things I'm going to grade when I grade your graphs. After you write the number on your paper, write the equation on every one. When you draw your graph, label your x-axis and your y-axis. That's going to be a point. Label the y-intercept. In this case, it's the point 0, 1. That's 1 point. Label your second point. Now, that one may be different depending on which direction you count for some people, but that second point needs to be labeled. The third point is that you draw your line, including the arrows on the end. So each one is going to be worth 5 points. Yes?
Is it okay if we have 3 points? Because I usually have 3 when I draw my line.
That's 3 points is fine. No problem. Okay? At least 2.
Right.
Okay? Any questions about that? Okay, let's look at number 2. We're going to graph the equation. Y equals -3x minus 2. What is my y-intercept? -2. So that means the point 0, -2 is on my graph. 0, -2. Now what is my slope?
-3 over 1.
Yeah, -3 over 1. If it's an integer, you assume it's over 1. So if I have -3 over 1, now, you can count this either of 2 ways. You can count down 3, 1, 2, 3, and over 1. Get that point. Or you could count up 3, 1, 2, 3, and left 1. Either one of those points is okay. Now I have to label at least one of them. So this is the point 1, -5. Draw your line. Extend the line. And put arrows on the end. And don't forget to label the X and Y axis. Okay, questions on those? Mr. Benson, sit up. Should be writing these down. Okay. When you see a graph or an equation that looks like this, this is the standard form of a linear equation. The standard form looks like this. AX plus BY equals C, and A, B, and C are all integers. Now, there's a couple of ways you can do this if you have an equation in standard form. So first thing we're going to do is we're going to check to see if it really looks like a line. Can I put this in y equals mx plus b form?
Yeah.
Okay, so to do that, I want to move the x's to the other side. So I get 2y equals -3x plus 12. Divide every term, and it does have to be every term, not just like first and last one, by 2. And I get y equals -3x plus 6. So there it is. What's my y-intercept? Plus, what did I do? 3 over 2, yep. Okay, so now, what's my y-intercept? What is my slope? -3/2. So, if it's in this form and you want to work with it in this form, that's all you have to do to put it there. Okay. Now I'm going to talk about the x and y intercepts. What are they? Just process the x and y axis.
How'd you do that? What was that last thing? I don't understand what was going on. You went way too fast.
Okay. Okay. It's just, it's an equation of a line. It's just that my x and y are on the same side of the equation. And that when it looks like that, it's called standard form.
Oh, alright. Okay, I see.
And then you can convert it to slope-intercept form, which is the one we're more familiar with. And if you wanted to graph it using that, you could, but you don't have to, and that's what I'm going to show you in this next part here. First, we're going to talk about intercepts. What would be the x-intercept? And I know it's hard to count little squares, but make a good guess. What would be the x-intercept?
-5.
-5, 0 is the x-intercept.
5, 0.
And actually, I think it's 4, but yeah, from there it's hard to count. Now, 0, 4. Now, one of the reasons I wanted to do this right here, the y-intercept, it's to get clear in your heads. The x-intercept happens when y equals 0. Because to be on the x-axis, Cash, y has to be equal to 0. The y-intercept happens when x equals 0, because to be on the y-axis, x has to be 0. Everybody clear on that? Because we're going to use that in the next slide here. So if So when you have an equation in the standard form, where the x and y are on the same side of the equation, the easiest way is to find the intercepts. So we're going to first find the y-intercept. Let's let x equal to 0. If I do that, then negative 5 times 0 plus 10y equals 20. So that's 0. So you 10y. So it starts 0 over here, so I divide both sides by 10, and I get y equals 2. So the y-intercept is the point 0, 2. Remember, x equals 0, y equals 2, so that's the y-intercept. So let's find the x-intercept. So then we'll say let y equal 0. So when I do that, I look at my original equation. Y is going to be 0. Negative 5x plus 10 times 0 equals 20. This is 10 times 0, so that's 0. Divide both sides by negative 5, and I get x equals negative 4. So the x-intercept is what point? Negative 4, 0. Now, when I'm going to graph this equation, and somehow I lost my grid, let me get one real quick. There we go. Okay, I have 2 points. I have the point, the y-intercept is 0, 2. I have the x-intercept is negative 4, 0. I can plot those 2 points. So I've got 0, 2. I've got 1, 2, 3, negative 4, 0. Label both of those, x and y. And draw your line between those 2 points. Remember to extend the line so it fills up your graph. And put on your arrows. Okay? One more thing I want to talk about, and that's a special case. Memorize these. Okay, the first one, y equals 5. If it's a line, what is the y-intercept? It's a horizontal line, you're right. It's a horizontal line. Where's it going to cross the y-axis? 5. 1, 2, 3, 4, 5. So I have the point 0, 5 on that line. What's another point on that line?
1, 5.
1, 5. 2, 5. We'll go out here so they don't run into each other.
7, 5.
Yes, 2, 3, 4. Okay, 1, 2, 3, 4, 5, 6. We got 7, 5. Okay, so anything that the y value is 5 fits on that line. Does this line have an x-intercept?
No.
No x-intercept because it is parallel to the x-axis. So this is, anytime you have y equals a number, it is a horizontal line. Okay, this other one is a vertical line. Okay, where's it going to cross the x-axis? Negative 2. What's another point on my line?
Negative 2, 7.
Negative 2, 7. 1, 2, 3, 4, 5, 6, 7. You just like that number. Okay, so then you can draw your line between the 2 points. Does this line have a y-intercept?
No.
Okay, it does not have a y-intercept. So anytime you see an equation that says x equals a number, it's a vertical line, and it's all the points where x equals -2, y can be anything. That's easy, you're right.
Okay, no the graph paper.